Okay, let's start with problem 1. So we know that Harvey has a fair 8-sided die, and we want to find the probability that he will. Did you just rename? Okay. We just want to find the probability that of the second number being greater than or equal to the first number. Okay, so we can actually we might as well just write out all the possibilities. So if Harvey rolls a 1, then for the second time, okay, hold on. Anyways, for the second time, if Harvey rolls a 1 the first time, then for the second number, he can either roll a 2, well, actually, he can actually roll a 1. So we can start that. He can roll a 1, 2, 3, all the way up to 8. And so if Harvey rolls a 1, then he can roll 8 different numbers for his second number. Now, if Harvey rolls a 2 the first time, then for his second number, he has to roll a 2, 3, 4, all the way up to 8 again. And that will give you 7 different numbers that he can roll. Moving on to 3, if Harvey rolls a 3 the first time, then he has to roll a 3, 4, 5, all the way up to 8 for his second roll. And that will give you 6 numbers. So just seeing this, you can find a pattern with each time he rolls a bigger number for his first number, then the number of possibilities for his second number decreases by 1. So following this logic, if Harvey rolls a 4 the first time, then he'll roll a 5. He can roll 5 different numbers for his second number. If Harvey rolls a 5, then he can roll 4 different numbers. If he rolls a 6, 3, 7, 2, and finally 8, 1. So when you add all these numbers together, 8 plus 7 plus 6 plus ... all the way to 1, that will give you 36. And you want the probability, so you want to put 36 over the total number of things he can roll, and that is 8 times 8. So 36 over 64 simplifies to 9 over 16. If you have a question, send it in the chat because I muted you all. Yeah. So question 2, you have a hexagonal table that by itself you can seat 6 people with 1 person at each side. Now this little diagram, it's made up of multiple hexagonal tables. So you want to find out how many tables are in this row for 50 people to be seated. So you have 2 types of tables. You have the tables at the end, and you have tables in the middle. Okay. So the ends, they each seat 5 people, and then the middle ones, they each seat 4 people. So in a row of hexagonal tables, you only have 2 ends. So the ends together seat 10 people. So basically, we just want to find how many middle tables there are. So we can do it by subtracting 10 from 50. And then we can divide by 4 to find out how many middle tables there are, and you'll get 10. So you have 10 middle tables. And To find the total number of tables, just add 10 to 2 because these are the ends. These are the middles. So 10 plus 2 gives you 12. Number 3, Kevin takes a bus home. So the bus travels 8 miles west, and then 8 miles north, and then 7 miles west. And we want to find how much shorter the trip will be if Kevin took this blue path right here. So looking at this diagram that I already drew out for you, if we extend this, oh, that's ugly. If we extend this to form a right triangle, then our lives will be much easier, and we can use the Pythagorean theorem to find the length of the hypotenuse or the straight path. So this vertical segment will be 8, and this shorter green segment is 7. Altogether, this is 7 plus 8, which is 15, and we can find the blue line by doing square root of 8 squared plus 15 squared, and that will give you 17. So the straight path, the blue line, is 17 miles long, and we want to find out how much shorter the trip would be. So we have to total up the route that his bus takes, which is 8 plus 8 plus 7, and then subtract 17 from that. So that will give you 23 minus 17 equals to 6. So your answer is 6. Question 4. So Tamika selects 2 different numbers from the random set 8, 9, and 10 and adds them. And then Carlos takes 2 different numbers from the set 3, 5, 6 and multiplies them. So we want to find the probability that Tamika's result is greater than Carlos's result. So we might as well just write out everything that Tamika can do, because there aren't many possibilities anyways. So Tamika can select 8 and 9. She'll add them together and that will give her 17. She can do 9 and 10, which will give her 19. And she can do 8 and 10, and that will give her 18. We can do the same thing for Carlos. Carlos can select 3 and 5, multiply them together, and he'll get 15. 3 and 6, 18, and then 5 and 6, and that will give him 30. So, looking at this, we can see that if Tamika selects, well, Tamika does 7. If she selects 8 and 9 for 17, then that will be greater than Carlos's possibility of a 15. And if Tamika gets an 18, that is also bigger than Carlos's 15. And if Tamika selects the 19 possibility, then Carlos has to have a 15 or an 18. So these 4 are the only things that satisfy the condition of Tamika's result being greater than Carlos's result. So we'll just have to put the 4 over the total number of combinations, which is 3 times 3. This comes from this and this. So that will give you a fraction or a probability of 4 over 9. And that's your answer. Problem 5. So you want to find what fraction of the interior would be shaded in the 8th triangle. So obviously you're not given the 8th triangle, but that is okay. First, let's just write out what fraction of the interior is shaded in each of these given triangles. So in the first triangle, none of it is shaded, so your fraction is just 0. In your second triangle, it is 1/4 shaded. In your third, it is 3/9 shaded. And we're not going to simplify these. We're not going to simplify these just yet. In your fourth triangle, it is 6/16 shaded. And we might as well just draw out the 5th triangle. So it should look something like this. And these will be shaded. From this, you can see that 10/25 is shaded in your 5th triangle. Okay. Now we can, just looking at the numerator and the denominator, we can find patterns for each of them. And for your numerator, we can see that this is just equal to 1, but this, the third triangle, is equal to 1 plus 2. And then 6 is equal to 1 plus 2 plus 3. This is equal to 1 plus 2 plus 3 plus 4. So that means, using this logic, using this pattern, for the 8th triangle, the numerator would be 1 plus 2 plus 3 all the way to 7. Okay? So for your denominator, though, you can see that 4 is just 2 squared, 9 is 3 squared, 16 is 4 squared, and 25 is 5 squared. Using this logic, we can find that the denominator has to be 8 squared. So this is equal to 28/64. And when you simplify that, you will get 16 is your denominator and 7 is your numerator. So 7/16 is your answer.